In this video, we'll talk for a few moments about a kite. And a kite is actually a special type of quadrilateral. It's not a parallelogram because all sides aren't parallel, don't show up in pairs that are parallel. And what I mean by that is this side right here is not necessarily parallel to that side. It depends on the shape of the kite, but most kites aren't like a perfect diamond. They actually have a longer tail down here than they do a point on the top. So if we look at the measurements of this one, there's some things we can figure out, and there's certain things we need to recognize. For example, the diagonals of a kite aren't like a parallelogram necessarily where they both cut each other in half, but look at this, the vertical one does cut the horizontal one in half. So you see this one is cut in half exactly. So we can use this to our advantage. This is a symmetrical diagram. It's a symmetrical shape. Basically, everything on the left half is like a mirror image of everything on the right. So, if we need to find some other measurements, let's use some of the things we already know. For example, if I was going to try to find this side length, okay, I have a right triangle. Okay? And this is something that will be true in every kite. You have a right triangle there. So I could use the Pythagorean theorem that says, well, let me write this differently. Says 8 squared plus 10 squared equals x squared. And if I try to solve that, I'm going to get 64 plus 100 equals x squared. So x squared is 164. That means x is the square root of 164, which probably isn't going to be a nice whole number, and that's all right. It doesn't have to be. If you put that into a calculator, you get x is about 12.8. Okay? And what you're probably going to see in your geometry book a lot of is, rather than just writing 12.8 and rounding it off, let's keep it exact, and we'll just write square root of 164. Or we could break it down and pull some whole numbers out of it. For the purposes of this video, I just want to show you some relationships. So we can go ahead and say that this side over here is about 12.8, and so is this side. Okay, x, this side right here, right there, and this side over here are exactly the same. They look the same in the picture, and because it's a mirror image on both sides, they are going to be the same number. Now, let's use that same principle to figure out, say, this side right here. I have 10 for the base of my triangle, and I have 20 for the height. So 10 squared plus 20 squared equals, and we'll call this y, equals y squared. That's going to give me 100 plus 400 equals, pretend that's a 0, 400 equals y squared. So I got 500 equals y squared, so y equals square root of 500, which is, and if we can type that into a calculator, we can get an approximation, or I'll show you a way to simplify it. That's around 22.4. Okay, but that's a rounded off value. That's not exact. Now, what you might see happen is something like this, and this generally is where people who didn't do so great in algebra or don't remember pieces of it get a little lost in geometry. Let's just look at this value. Okay, we know that it's about 22.4, but to write it exact, we could do this. The square root of 500 is the same as the square root of 100 times the square root of 5. All I did was break it into 100 times 5, which is 500. Now, the square root of 100 happens to be a whole number. That's 10. Square root of 5 is not a whole number. That's an irrational number, a decimal that goes on forever. So I'm going to write that as square root 5. I'm not going to change it. And what you may see in your book sometimes, instead of having decimals, you're going to see things like this. 10 square root 5 as this measurement right here for this line. And just because there's a radical written there doesn't mean anything, okay? It doesn't mean anything different. It's still a decimal that you don't know. It's just one of those decimals that never ends, and instead of rounding it off, we'll just keep it exact by leaving it as a radical. Something we just have to get used to seeing.